Hi, my name is Allison Presmanis-Hill, and I'm a professor at Oregon Health and Science University in Portland, Oregon. Today, I'm going to walk you through code to read data into R using tools from the tidyverse. To get the most out of this, you will need experience using the library function to load packages into R, an understanding of vectors and tibbles as objects in R, and experience using the pipe operator from the dplyr package. Also, some experience looking at text files may be helpful too. We'll be using a dataset that is publicly available through the Harvard Dataverse. This dataset was associated with an article published in the journal PLOS One. In this study, the researchers were interested in examining factors that influence children's sharing behaviors, which they measured by counting the number of stickers that kids donated to other kids. So let's go ahead and get started. I've provided here the link to the dataset on the Dataverse website. In my R console, I'm going to create an object called link, and I'm going to assign it this character string that holds the URL. This is going to decrease the amount of typing that I'll need to do later. Now the main package that we're going to be using to read the data into R is the readr package, so make sure that that package is installed and that you load it into your work session. So the first step in any data import process is to look at your data. You can use this link to download the file and open it using a spreadsheet program like Excel or a simple text editor. The most important thing that we need to figure out from looking at the file is how the fields are separated, because that's important information for us to pass along to R when we import our data. So the first thing I'm going to do is look at the file name extension. It's a .tsv file, which stands for tabs separated values. The tsv extension tells me that we have fields separated by tabs. So let's open it up and take a look. You can see the row numbers here on the left in my text editor. And it looks like the first row consists of variable names separated by tabs, like subject number, condition, number stickers. The second row is a little bit more confusing. It looks to be longer strings, also separated by tabs, but those might be a problem when we read our data into R. The data seems to start at row 3, and it looks like mainly numbers that are sometimes in quotes, but sometimes not. So all of these are important things to consider when we're reading our data into R. So I'm going to close out this text editor and head back to RStudio to read the data in. So armed with the information that we're working with a TSV file, the right function for the readr package is the Read Tsv Function. So let's create a new object called stickers and use the function Read Tsv. Now the primary argument for this function is a path to a file. It could be a path to a file on your computer, but it could also be a URL, which in this case we have. So we're going to enter a link as the primary argument here. You can see that readr printed some information to our console. So the variable names are on the left, and on the right side of the equal sign are the variable types. readr uses a heuristic where it scans the first 100 rows of your data set, and based on that, for each variable, it predicts a variable type. So you can see that the majority of variables here have been read in as character variables, which is surprising, especially for variables named number stickers and number envelopes, which sound like they should be integers. So already we have our first clue that something may have gone wrong in our data import, because the variable types do not look right here. If you want to call this output back up later, you can use the function spec to see it again. The next thing we'd like to do is get a high-level overview of our data. I call this saying hello to your data set, and there are a few key functions that are helpful here in R. The first is from the dplyr package, and it's a function called glimpse. The output here shows me the number of observations or rows present in my data set, so we have 402 here. I have 18 variables, and the variable names are listed below in the first column on the left. You can also see that it tells me again the variable types, just like readr did. You can also get a glimpse of the first few values that are present in each variable. So this output looks like there's more to it, but it looks like it's cut off, possibly because I have a really long variable name here. Another function we can use is head. This provides us a glimpse into the first 6 rows of our data set. And here we can already see a problem. So it looks like the first row of my data set is not actually data. It looks to be more like a data dictionary or notations about what is stored in each variable. This row is probably the reason that readr thinks all of our variables are characters. It's likely messing up the ability of readr to predict the right variable types. So for example, all 4 of these variables that I can see contain numbers, and yet they're read in as character variables. Similar to head, we can also use tail. And this shows us the last 6 rows of our data set. Here you can see that I have 401 subjects included in this study. And yet, if you remember in the output from Glimpse, we saw that we have 402 rows of data. So again, this is telling me that I have an extra row of data that should not be there. A final function we can use is names. The output of names is a character vector that contains all of the variable names for the data set. And this is going to be really useful to us later on. Finally, you can view the data set by using the RStudio viewer by clicking on the object here in your environment on the right. This gives you a spreadsheet view of what your data looks like in R. And again, we can see that that first row is a problem across the board. So we have diagnosed the first problem, which is that the first row is not data. So how are we going to deal with this problem? Well, we're going to read in the file again, but this time we're going to do it in 2 steps. I'm going to use the Read Tsv function in each step. In the first step, what I want to get out of it is a vector of column names only. So I'm going to use here a sequence of pipe operators to get me there. I'm going to create a new object called sticker names. And I'm going to start with my link. And the first function I'm going to use is read tsv. And I'm going to use a new argument here called in_max. And I'm going to set it equal to 0. Now what this argument does is it tells readr to read in none of the data rows. But because the default for column names is set to true, readr will only read in the first row of my data set it to the column names, and then read nothing else in. The next function I'm going to use is rename, and this is from the dplyr package. And I'm going to use it to rename that really long variable. I'm going to call it now stickers given. And on the right side of the equal sign, I'm going to put the original variable name. And I'm going to copy and paste it from the output up here because it's so long. You'll want to make sure it's in quotes. Finally, we're going to use the names function, like I showed you above. So what have we done here? We've started with the URL, the link to the data file, and we've used the Read Tsv function to read in that file with the in_max argument set to 0. The next step was we renamed a variable that was so long that it was silly. And then the final step was to take the Tibble output from the above functions and apply the names function to it, which creates one character vector of column names. So let's see what that looks like. Let's say hello to sticker names by taking a glimpse. So now that I have my column names saved as an object called sticker names, I can read in my actual data, which is the second step. I'm going to create a new object, again called stickers, which will just save over my old object that I was working with. And again, I'm going to start with the link, and the function I'm going to use here is the Read Tsv function again, this time with 2 new arguments. The first is skip, and I'm going to set that equal to 2. So that tells readr that I want it to skip the first row, which was my original header row that contained the variable names, and the second row, which was that problematic row that contained strings that seemed to be part of a data dictionary. Now, because I've done this, I need to tell readr where to find my column names. And where it can find the column names is in that object I created in step 1, which I called sticker names. Let's say hello to stickers by taking a glimpse. Now you can see that I have 401 rows or observations. I have 18 variables still, one of which is significantly shorter. It looks like the variable types were read in correctly now, and I can see that they match what is present in each of the variables. So success, we are done. We started by using Read Tsv to read in our data using only the default arguments. We said hello to that data, and it responded by saying try again. So we then took a 2-step process, using Read Tsv in both steps, but using different arguments each time. We did this to ensure that the column names and the variable types were read in correctly. Thanks so much for watching this video, and I hope you have seen how readr is a powerful tool to have in your toolbox for reading in tab-separated data.